Okay, so good morning, everyone. So we are happily inviting you for our today Docker session. So and this is Veera. So maybe let me share my screen, and then I will walk through what we are going to discuss about today. I hope my screen is also visible. I think, guys, if you are not able to speak, you just respond in the chat. Okay. So I hope my screen is visible here. Okay. Okay. So today agenda is we are going to look into about the basic fundamentals of Docker, why we need the Dockers, and then what are the problems we are facing, and then how it's solving the real world use cases with using usage of Dockers. Okay, and then what are the components it has, how the architecture workflow is working for a Docker. That's also we are going to look into about, and then how to create the Docker files. So first we will check what is Docker file, and then what is Docker compose, and then how to create our own Docker file and then Docker compose file also we will look into that. And then finally, this is the demo part, how to Dockerize entire full stack applications. So how we can Dockerize the front end application, how to Dockerize the backend, and how to Dockerize the DB, and then how we can compose everything in the single file. So that everything we will look into it today. So that is the today agenda. Then next, okay, let me introduce to myself. I'm Veera. So I'm working as a senior software developer at Tech System. I'm having 4+ years of experience in various domains such as GIS, e-commerce, supply chain, and decentralized finance also. So I am also one of the co-organizer of the Cloud Native Madurai community. So other than I'm actively participating some of the conferences as a speaker and as the organizer. Also, I'm writing some blogs which is related to full stack blockchain and cloud related services. I'm continuously contributing and writing some articles also. This is all about myself. Then okay, so let's get into the session. Before start that, I want to know how many of you currently using Dockers. How many of you already have a knowledge in the Docker? If you are having, you just raise your hand. So requested for presenter mode. Just a second, I will give. Okay, yeah. Yes, Suresh, I think I have the request moderator, so you just started, just now started AWS. Yes, okay, cool. Okay, fine. So you already familiar with okay, Docker, the basics also you are familiar with. Okay, cool, fine. Okay, guys. So let's back to the session. So the Docker wise, it's very simple tool in based on my understanding. I'm saying in the theoretical part, and then how it's working, and then the learning perspective also, it's very simple. We have to just learn about very minimal amount minimal commands we have to know about that. Okay, so what is the purpose why we need the Docker is in real world, there is some inconsistent environments, like in our software development life cycle, our developing the application in one kind of environment and deploying the applications, sometimes it will be in different environments. Sometimes you have to develop your application in Windows system, you have to deploy your application in Linux system, right? So the packages and everything will be uh, not consistent, something will be inconsistent, right? That's also a problem we are facing it. And then dependency wise also, so dependency, sometimes you have to install based on your environment. Some you are developing in Windows system, so Windows system supporting dependency you have to install. But your deployment side, you have to use some other environment, then that kind of dependency you have to use it there. And then the resources wastage is also that is one of the concern. Like in if you are in your system you are not sure about how much resources utilized for particular application. That's also very very another one reason for using Docker also. And the deployment complexity wise also, so you have to get everything, every part of your application, and then you have to push somewhere. Okay, you have to take it, move your application to another environment. You have to add all the dependencies, all the environment, all the configuration, everything. You have to move it there, so it looks some complexity. Okay, and then the scaling wise also it's very challenging. Okay, so sometimes uh, your application uh, receives lots of network, lots of requesters. At that time, you manually we have to scale our application instead of auto scaling it. So that's also one of the challenging. In security perspective also, it's very very complexity without Docker. Okay, and then limited portability. Portability means moving our application one platform to another platform. These are the problems in real world we have. So okay, so this is the part the Docker also playing their role. Okay, so Docker will help us to maintain the environment consistent to all the platform. Okay, so in your Docker, in your current system, you can set up your um, environment for your application through Docker. Okay, in Docker you can mention, so okay, this application will use Linux. Okay, in particular Java version is going to use. So same version, same environment, you can use it for another platform also. In like you are using Windows system for your development, in Linux system if your for deployment, so same environment you can maintain it for all the platforms. Dependency wise also, you can compress and compose everything in the single file. Resource also, how you can know about how much resources it's utilized. Okay, and then deployment wise also, it makes you very very easy. And scaling wise also, so first time you are deploying one Docker images, if you want to scale multiple applications you through Docker, we can make it possible. Okay, in security wise also, it will be very very helpful to analyze what are the vulnerable uh, features it has. That's also we can do it. And then portability wise also, it's very very helpful. We can easily send our deliverable to other users. Okay, so these are the points we can consider why we need a Docker. Okay, so okay, let's check what is Docker. So basically it's isolate the entire applications from other resources. Okay, for example, if you are running your application in your system, so the your application also will be the part of your system. Okay, this is how the normal software development will work. But if you are using a Docker, it will provide isolated environment. So it will provide the separate uh, file system for your application. It will allocate the storage and resources which only required for your applications, that will separate, it will be allocated. And then the standardize the packaging wise also. So for example, let's take the problem, like let's take one of the use case of Python related applications. Okay, in the Python related applications, we can have a two different kind of environments. We can see that, like if you are installing any packages in using pip command, okay, it will two different way it will be installed. One is virtual environment, it will be installed. Another one is it will be installed in your system configurations. Okay, so that kind of things it will be avoided. So you can install your own packages which is relevant for your applications. It will be isolated here. Okay, so it majorly it's work with uh, most of the Linux and Windows server also, it will be supported. To simply says, basically it will provide isolated environment for your application. There you can move, there you can install all the packages, all the configuration, everything you need, you can move it to that. So that is the simple point of view for the Docker. Okay, so the next, let's see what is the Docker architecture, what are the component it has. Okay, so basically it has the overall architecture is, it has three different categories. First one is the client side, second one is the Docker host, okay, and third one is the registry part. Okay, so the client side we have to install some the CLI tools. Okay, there we can communicate with run some Docker related CLI commands, so that will interact with our Docker host. Okay, like a client server architecture. Okay, so the Docker host will have, it will work like a server. So it has Docker daemon. It actually receive all the requests from your client side, okay, and then it will schedule some processes. It will do some actions and everything, okay. So other than in the Docker host, we have containers and images. Okay, let's talk about what is container and what is images. So basically, Docker image is nothing but your application, okay. So for example, if you are running your uh, Java application, right, so you can convert it into the Docker image. It's called single source file, okay, isolated file. It will be easily deliverable to others. Instead of you have to copy all the files and push it to the git, you can compress and everything into the single image, single Docker image. All the packages and everything will compress into the single file, so you can easily deliver it to other users also. So we will look into it how it's working in the demo part. So for the theoretical part, it's like your application will be compressed into the single file, okay. And then what is Docker container? Docker container is, it will provide the environment for running your Docker images. For example, if you want to run your Java application in your system, what environment you have to provide? You have to provide some system resources, and then JDK, and then the runtime development kit, and then the environment, everything your system will provide, then only your application will run, right. So that same things your containers will provide, the same resources and everything for your Docker images, okay. So this is the difference between containers and then image your application, and containers will provide the support for your to running your application, okay. So and then what is registry? Okay, so for now everything is happening in your system, okay. Creating your Docker image, creating your Docker containers, everything you can do it in your image, okay. And then you have to pass your Docker images to someone or some other platforms, okay, then only it will be deliverable. So that reason, you have to push your Docker image, you have to publish your Docker image any private or public repositories that they are calling as a registry, okay. Like how Git is working, so the collaborative environment, right, same thing registry also doing it here. You have to push your application image to a registry, okay. Someone will take the image and then they can deploy it, and then they can also push the latest version of images and everything they can do it. So this is the overall architecture and then components Docker it has. So that's it. Like this is very very simple tool. In the learning perspective, it's very very less component. So now let's move into the demo part. So firstly we are going to look into about what are the commands it has in the Docker, what are the commands we have to learn, and then we will look into about how to Dockerize the full stack application, okay. So let me share my screen just a second. GitHub. So this is my link, GitHub account. So here you can see a Docker Masterclass, okay. So the basics part, you can see the most of the commands. So first you need the Docker setup in your system. So I mentioned the link here. You just go and check. So here you can see Docker tool based on your system. So if you are using Windows, you can install, you can download and install it. In Linux, that command also they are providing it here. You just follow it to set up the environment on your system, okay. So in my system, I think once you install, you just verify it with Docker version. So maybe let me share it. Okay, so here you can see the Docker version here. So that means it's installed properly. You can also verify in that way. So the next one, so for example, these are the basic commands. So if you want to list out what are the images you have in your system, you just run Docker images, and then what are the containers it's running, what are the containers it's currently running, that's also you can use docker ps. Okay, so let me execute the commands one by one, you can verify it. So list out all the images, you just run docker images. So it will list out what are the images you build, and then what are the images you download and available in your system. Okay, and then if you want to check what are the containers are running, docker ps hyphen a, so it will tell you these are the containers are currently running in your system. Okay, so for example, if you want to search the particular images available or not in the public repository, you just docker search CentOS. This is the CentOS image, let's see. So you can get, yes, it's available in from various names. So if you want, you can choose any one of the images here, and then you can install it here. Okay, and then if you want to pull the image, just run docker pull CentOS. Okay, so I'm not going to pull the image, maybe it will take time. So you just take a look what are the commands are available here. Okay, so and then this is the command for pull the particular docker image and store it in your system. And then next one, how to build the docker image. Build the docker images means how to dockerize your particular application, what command you have to do it. Okay, so this is the command docker build hyphen t, means the tag and then image, your name you are going to give it for your docker image, your application, and then the path of your docker file. So how to create the docker file, we will look into it later. So the path also we have to mention it here. Okay, this is the command we have to use it for dockerizing, creating docker image for your application. And then to run the particular docker image and containers, you just docker run, and then the particular image name, if you mention it, it's enough. And then it has some other parameters also, like these things, like this one, the building docker image, and then docker run the docker container. We will check it in the demo part, like we are going to containerize the full stack application, right? That things we will execute it there. So you have to pass the port, what will be your container port, what will be your host port, like internal port, what is the external port, that you have to mention. And then if you are using any volumes means your data will be persistent, your data will be stored in any one of the particular file storage, what is the path, that you have to mention in the volume section. And then if your particular application have any environment related stuff, that you have to mention it here. Okay, so that is um, these are the parameters we have to pass it for while running your docker containers and images. Okay, so if you want to stop particular container, you just run docker ps, it will list out all the containers. Okay, I want to stop in this hello world. Okay, so I just docker stop de6. You can mention the entire id, this is the container id. You can mention the entire container area, or just 3 to 4 words, that will be enough to find out the docker container. ps hyphen a d6 ed. I think it will be stopped later, maybe exited. Okay, so it's stopped actually. Docker 7 days. Okay, it's already stopped. So there is no container images. It will tell what are the containers are previously running. Okay, the docker psa. So docker psa, it will tell what are the containers are currently running. So right now no containers are running here. So if you want to remove particular container, that's also you can mention docker remove the particular container id. If you want to inspect, like inspect means if you want to go and check the particular container, so you can run the inspect command, and then the particular container id, the same for the nginx. Okay, so you can we will check this in the full stack application. After container server full stack application, we will execute it everything. Okay, so for example, if you want to go to the particular container file system, which we already discussed, right? Docker will provide isolated environment, isolated file system for your application, right? So there you can see the same exact your operating system file system structure, you can see it there, so that we will check it later. So these are the overall commands we have to learn for the Docker tool. Okay, so now I hope you are clear about the basics of Docker. Now let's move into the advanced part. So there is one folder for advanced. Here you can see there are two applications, web app and then Golang. We will clone it here. So I will clone. Okay, so I will open it in my code editor. So I'm using Visual Studio Code Editor. I would suggest you to use the same, so it will really helpful for your development purpose. So the basics we already discussed about everything. So advanced part, we can see two applications. Let's see how the application is looks like before Dockerizing it. So this application having Golang backend system and React is the front end system. It will communicate with MongoDB database. Okay, let me check my MongoDB server is running or not. Okay, it's not running. So let's start. So systems ATL. So now, okay, so my Mongo server is running here. So now let's run the application. For a Golang application, you have to run to install all the packages. Go mod td. It depends on your own applications, and if you are using Java, you have to run Maven command. If you are using node related applications, you have to run npm install, right? So something similar for Golang here. Go mod td. So and then once it's installed all the required packages, then you have to run go run dot. So it will take the entry file main.go and then it will connect and run the application. Okay, so now my backend server is running here, database is connected, and then server is running in 8000 port. So now let's move on to the front end side. So my front end application is the React.js application. It's a environment is node npm. So I have to run npm install to install all the required packages. Okay, so you just note it down. What are the commands we are using to run our application? Same commands, almost it will be something we have to change it, but almost it will be same while creating the Docker file. Also, there's almost the same commands we have to use it for creating while creating the Docker file. Also, for example, here I'm used uh, go mod td, right, and then I'm running go run dot. Uh, File also. This is one of the way we can run it for the Docker for Golang applications, but it's another one way we can take the build and then we can run that. So there are two ways. So for now I'm just using go run dot. So almost similar, what are the commands we are using it for run the application. everything will be mentioned in our Docker file. Okay, so in the right side in the web application, I'm using npm install and then npm run start. So these are the commands I'm using it here, right, to start the application. So in our Docker file, we have to mention it here. Okay, so this is the sample application. Basically, it will do some creating the member test test.com Chennai. So it's created the member and then I can edit them. It will just do the user management part. That's it. So I can delete the user also. That's it. So this is the front end and back end system we have. So we are going to Dockerize this application. So now let's back to the code. So first we will create the Docker file for our backend code. Then we'll create the Docker file for our front end code. I will stop everything and then I will stop the my MongoDB server also. Okay. So now let's go to the backend application. In backend go -API, here I meant creating the Docker file. Okay. So here I have to mention what are the packages, what are the dependencies it's required, what are the commands it's required for running this backend application. Okay, so it will differ, uh, depends on the language and tech stack we are using it. So here is the Golang. So for Golang, I need Golang 1.19 Alpine image. Okay, so this is the base image it's need to run the application, and then I'm setting my working directory. So where this application will move to your containerized file system. Okay, so I mention it should be in backend. Okay, this is my working directory, and then I first I want to copy my dependencies, my packages for these applications. So in for Golang there are two files, go mod and then go sum. These two packages maintain all the packages for um, your Golang application. It will differ for your Node.js and then Python and then Java related application. These commands will differ that. Okay, so you have to mention where you are maintaining your the packages and everything. That command you have to mention, that file you have to mention it here. And then I'm running, I mention run command here to install all the packages. So go mod download. So it will download all the packages which required for this application. So in your go mod file, you can see all the packages here. Okay, so this go mod download command will check go mod file and then download all the packages. So the next, okay, now I download all the packages. Now I am creating the executable files. Okay, so Golang is almost similar to your C and C++. So it's a kind of compiler compilation language. So first it will create the execution file and then it will run the execution output. Okay, so I'm running, and then one more thing, I'm copying other files also. First I copied go mod and then go sum to my working directory. Now I'm moving all other files also, I'm copying it here in my current directory. to my working directory, like in the Docker side. So and then I'm running, creating the build main dot. So it will create the main dot executable files. I'm exposing the port at 8000. Okay, and then I'm running the command, which is dot slash main. So main file will be created after this command. Okay, so I'm running the command here. So this is how we have to create our Docker file for our application. The same things we can run it here also. Like I used to go build, right? Go build hyphen o main. Here you can see the main file has been created, and then I can run the main file. It will not run because it will try to connect with the backend system database, because we stopped our database system, so maybe it will not run. But in our containerist the Docker system, we will check that it will work. Okay, so whatever commands we are using it to run the application, that everything we have to mention it here in our Docker file. Okay, and then we have to create another one file which is called Docker ignore file. So that means sometimes you install in your project, have installed some of the packages folder, also some output folder also will be there. Here you are moving all the code to your Docker container, right? So it will try to move that files also, the packages for folder also it will try to move. So that file we don't want that. So that everything we can mention it in the Docker ignore folder. It's kind of I hope everyone is using Git. You can see Git ignore file, right? In the Git ignore file, you don't want to push some other files. You don't need that, right, to push into the your remote repositories. Same here also we can use Docker ignore. So here we can mention what are the folder and files we don't want to move it. So I already created Docker file. I will just replace it here. Okay, these are the basic file path and everything for our Golang applications. It will differ for your own applications also. If you are using Maven, like if you are using Java, for Java application, the output and packages folder name should be different, right? That folder name you can mention it here. Okay, so that's it. Now let's create the Docker image for your application here. Okay, let's see what are the image I already have. So I already have Golang Go AP v1.000. Maybe we will update the tag here. Okay, so we already discussed what is the command to create Docker file, right? So Dockerize the image. So this is the command we discussed, Docker build hyphen t. So we will use it here also. Okay, so Docker build hyphen t, and then I mention Go API and mention the tag 1.0.1 here, and then the path. So in the Docker file, the path is in the same Golang folder. So I mention the dot here. So it will take all the commands we mentioned here. So it will execute it one by one, the layer by layer it will be executed. Okay, okay, while it's okay, it's done. Cool. So now let's see. So this is our image and tag version, right? Let's see it's created or not. So Docker images. So here we can see Docker API. This is our latest image. Okay, so the file size is 600 MB. Why it's 600 MB means, so the all the packages and everything is isolated in a specific path. So in your Docker image, all the packages, everything is moved and downloaded there. Okay, so now let's create the Docker file for your web application. It's the same. You have to create the two file here, Docker file one, and then Docker ignore file is another one. So for your web application, what environment we are using? This is for a Node.js, right? So it's a React application. Node.js environment is using. So I have to mention Node. I'm using 16 image. So whatever environment you are using it, you can mention it here. Okay, and then I mention my working directory. It should be app/web app. This is my working directory. There you can see the files and folder, everything. So and first I want to copy the packages related files. So for Node.js, the packages, everything is mentioned in the, just a second, I will mute it for sometimes. Okay, now we are good here. Yeah, sorry guys. So okay, let's back to the Dockerizing the front end application. So for the Node.js, packages related file name is package cage.json. If you're not sure about, we will go and check that. So the package log.json and then package.json, it has all the packages, everything. Okay, so I mentioned package star.json. So it will take both package.json and then package log.json. I'm moving to my working directory in our Docker system. Okay, and then I'm install all the packages using npm install, and then I'm copy the remaining files also, and I'm running npm and build. So it will create the build folder. Basically in the production level for front end application, they will use nginx or some other web server they are using to serve your static application or dynamic application. So that case you need this build file, build command you need. But in demo purpose, we are not using I'm not using the nginx here. I can just directly run the application. So I just need npm start. That's enough. So we can ignore this command. This one also we can ignore it. It's not an issue. So this is enough. I think npm start, npm. Okay, this is the Docker file for our front end application. So now let's create the Docker image. So what command we have to use? Docker build -t web app v 1.0.1. That is the new Docker image version, and then the path will be the same path. So the web path, they can see the Docker file, so it can take it from there. Okay, so it start to install all the dependencies and environment here. So it may take sometimes, so we will wait for that. Okay, so now we have a backend Docker image, and then front end Docker images also we have it. So what else we need for our running the applications? We need a Mongo also, right? MongoDB also we need that. So that we will check into the Docker Compose part. Okay, so we will talk about why we need Docker Compose. Is for particular application it has many containers, right? So how we can maintain many containers, so how we can compose it, everything. So using Docker Compose we can organize all the images and services, and then through the single command we can start all the services, and then we can stop and everything through the single command. Okay, so that we will check that, like okay, it's running. We will start to write the Docker Compose file also. Basically Docker Compose file will help us to compose, organize all the containers and managing and everything. You can do it through Docker Compose. Okay, so in the root directory I'm writing Docker Compose .yml file. Okay, so here I am going to mention what are the services I'm using it here. So first I have to mention the version. What is the version I'm using? 3 version, YAML 3 version I'm using it. Services, what are the services I'm going to use? The front end service I'm going to use that. So where it's going to take the build, the build file and Docker file, everything. Okay, so here you can see Docker web application Docker file also created. So Docker images. So the latest version, web app version 1.1. So it's almost 1.02 GB. It means all the packages and everything is installed and compressed here. Okay. So now let's create the Docker Compose file. Okay. So I have to mention the front end services where it can take the Docker file. So in the web app folder it can take the Docker file for the front end services running. Okay, and then what port it will use it to run? The port will be 3000. External port also 3000, and then internal port, what port the application is using to run. So 3000. Front end is done. Next, backend, where it can take the build in Go API folder, it can take the Docker file. Okay, so what will be the port there? My backend, it's running 8000 port. Okay, so what else we need? We need a Mongo also, right? So basically what it will do, it will create the network. Okay, in the all the containers and everything, it will create the network. Through the network it will communicate it. So the front end, and then front end Docker container, and then back end Docker container communicate through the network, and then our backend Docker container, and then the DB container also through the everything should be in the same network. So that's also we will look into that, how the network is creating it, so that everything we will check it here. So I want to install Mongo service, and then image. What image I'm using? I'm using Mongo 4.4.4 bionic image I'm using it. And then the volumes, why we need the volumes is my DB should be persistent, like the data should not be deleted at any cost. So so that means our data and everything will be stored in your host file system, your system file system. So then if you stop your application, if you stop your container and then you restart that, it will check the file system and then get the data from that. So that's the reason we are using volumes here. So I mention my path where my data, everything should be stored, and then the port, which port it should run. It's usually 270117. The Mongo server should run 27017. Okay, and then here I'm going to mention one more thing. My server, my DB is running. I want to check my DB and every time, like a health check something. So there is some commands there. So I will just make it. Uh, Already I'm having. I'm just going to replace it here. Okay, this is the command to check health, the health of the database. So it will run mongo command and hit the host and get the DB details. Okay, for every 30 seconds of interval. So it will, this particular command execute and then check my DB is alive or not. Okay, so and then I mention, so the volume. So here I have to mention the volumes mongo dot data. So, okay, so the Docker will take care of that. So for example, you are using the particular path slash data slash db for your database, right? For example, if your backend system also going to store some data, you can mention volumes mongo fun data dot slash data slash backend. Okay, in the particular folder your backend data everything will be stored. And then same for your front end application. If your front end application going to store any data, you can mention your path here. Okay, so for now it's not going to store backend system, so I'm just removing. So okay, now our Docker compose file is created. So this is how we have to organize all our containers for our application. Okay, so I mentioned front end application, back end application, and then DB also and everything here, and the volume mount also I mentioned here. So now I think we are good to start the entire application at the single command. Okay, doc. Let's go to the previous directory and then let's see. So Docker compose file is placed here. What is the command we have to use? Docker compose up. So this command to up all the services and everything. Okay, so here you can see the network, right? So the default network will be created. Okay, and then it's creating mongo. If it's not there, it will try to download and then it will use it. Okay, if it's already there, it will take the existing image. Okay, so my all the containers, everything's connected through this advanced the default network, so it can communicate with each others. Okay, so that's one thing. So here you can see various logs. So this is the mongo db log. Okay, my database also connected, mongodb connected successfully. Okay, so front end is, I think, is trying to start. So every 15 seconds, I remember 15 seconds or okay 30 seconds it will check the health. So that logs we can see it here. Okay, okay, I hope my front end application is also running. Let's check the close it. The same port, the 3000 port we are exposing it here. So that's it. So now I think our application is started to run here. Okay, so that's it. This is how we have to manage all the containers for your applications and everything. Okay, so I hope, I think I covered all the topics and everything. If you have, I will share the link with you, like the document, everything with you, so you can use it for your learning purpose. HTTP in this one. So there are two branches you can see. So first one branch, it's a default the normal application. The second branch is the final branch. There you can see all the Docker files and the Docker compose files, everything will be there, so you can use it. Okay, so I will share the repo with you. Yeah, EST. So I think I completed from my side. If you have any queries, any doubts, you feel free to ask. Yeah, you have any doubts, you feel free to raise your hand. So I think you can speak. I think, yeah, or you can ask your question in the chat also. Okay, so if we are good, yeah, I hope this session is uh, really helpful, uh, made some values, insightful values to your learning. So we will discuss about the next session, or I think it will happen by end of this month. It will be the Kubernetes session. Okay, so that we will learn the basics of Kubernetes, and then how to deploy the full stack application through the Kubernetes. That we will discuss about the next session. Okay, so I think if you have any queries, you can ask. Other than we can end up this session. Yeah. Okay. Cool. So yeah, thanks, guys. Thanks for your participation. Thanks for your interest. So share your feedbacks. We are very happy to receive your suggestions and feedbacks also. Okay. So we will be available in LinkedIn. You can feel free to reach out at any time. Yeah. Thanks everyone. Thanks guys. We will meet in the next event. Yeah. Thanks everyone. Thanks.